Hey guys, well, I'm glad Marek is here because our only item is still the 4-bit, um, 8-bit or the narrower bow slices. I have to ping Shahab about optical, and we're still lacking a volunteer for test. We don't have anybody who's willing to take up the test. Kevin, is there anybody in your org by any chance who's interested in adding some test features?
I don't think so right now.
That's a sort of painful gap right now.
What do you mean by test features? Like part of the standard so that the standard defines test features?
Well, Satya used to show up, but he isn't now. But the idea when we wrote it down was that we wanted to put in some BIST. We have some, but clarify what we have for package level test, package level test and system level test. I think wafer sort is out of our reach anyway right now.
Yeah, makes sense.
But we don't have anybody who's sort of in that zip code.
Yeah, I wouldn't know of anyone off the top of my head either.
And Shahab is on the optical side. He's got some ideas, and I got to figure out. Okay, so it might end up being a short meeting if you guys, you gentlemen, are already in agreement on the new features that Ahmad has proposed, or do you want to go over that?
Sure, yeah, we can talk about it again. I mean, I sent an email to, or Kash had sent me the updated presentation. I watched the meeting afterwards, and I sent some feedback to him and Ahmad. So I think, yeah, generally I think it all looks pretty good. It's just what came up last week during the discussion, basically to what degree will this be interoperable with, say, a PHY that has been designed before, like the IoT spec in mind.
So I think Kevin had that same question. Was it Kevin who had the same question about, is this really like is this a mode or a completely different interface?
I mean, that was basically my question. Elad and I were talking about it. I mean, I understand the concept that was presented. It makes, it could be a good fit in certain applications. It is almost like a different spec in the way it's trying to define clocking versus data. It's not like a different mode of the same, BOPHI. So I don't understand how this within this organization gets handled. Is it an addendum, a separate spec?
For that we have a fairly reasonable process. We simply we have this notion of operating modes, right? So
Okay.
And then you kind of say, like, you decide which modes you want to support in the basic definition.
I see.
Like way back when Ramin's bidirectional was one mode, basically. Before we yanked it. So it is basically this can end up being a mode, and somebody can decide whether they want to support that mode.
And so can I just add a couple of things? So there's
no, please, whatever you do, don't.
So there was two pieces to the proposal, right? Making the clock to the center, that can be basically completely what you call adaptable to the old things, because it's basically following the same physical. You just send out 0 or receive zeros, right? on the other ones. It just makes it a bit more symmetric. So that would be whatever we're sort of, if the other half phi is adaptable, this one would be as well. It's the it's the part that we split the transceive and receive, and we can do both on the same phi, that the older stuff would not be able to do that, which I'd assume there is no older 8-bit phi. But basically this would be an additional mode. But this mode will operate with the other both modes as well. So it's an additional mode when we can do a split.
Yeah, I think that's what I was thinking as well. Like it makes sense that, like, say if the phi that you're intending to build that basically can talk to an existing Bo phi, basically by forcing that all lanes go in one direction. But
Yeah.
the whole thing of having RX and TX in one slice, that's what I mentioned in the email. At least my notion of it was that it was always clear that one slice, no matter how small, like if it's 8 or 16, always goes in one direction and brings its own clock. And so
Yes.
that is what you're changing.
Well, it's yes, both that there's R's and T's, but there's still only one clock going in one direction, and there's no
Exactly.
clock that's returning with the received data. That makes it a little bit difficult to implement, but quite difficult to spec. And that's what Elon was worried about, was there's some heavy lifting in his words as far as how to draft specs when you don't have a reference, timing reference.
Yeah. So I mean, I guess that the spec is what we came up with, right? The question is making it work, making previous one work with it, which we can't. So this is an additional mode.
Question. So
Wait, there is one thing I don't know whether Elad brought it up last time. Somebody brought it up, and that the clock is part of the wire order, and this one changes the wire order relative to the original spec, correct?
For which one? For the
Would you mind
So-
sharing your screen again with whatever your proposals are? Maybe that makes the discussion easier.
I don't
Are
have
the
it
slides
actually.
posted somewhere? I don't know how you organize the space, Poppy.
Wait, what?
Were the slides presented last week posted somewhere? So we could
No.
reference after the meeting? Or just you have to go to the
haven't yet.
recording?
No.
Okay. Yeah, if you could share them again, Ahmad, that would help.
Sure. Oh, yeah.
So I guess Poppy has it. I don't know. I guess can you? I don't know how to share it for everybody. What's the best way of sharing it?
Oh, yeah, but I'm just talking about now, like on your screen.
You just shared the screen.
So for that, you need to give me like a couple of minutes or a minute or two.
Sure.
Because yeah, all right, give me 1 second.
But I think we do have a requirement that any new Bo mode we define be compatible with other modes, and that gets violated here. So then it's no longer a mode, but a whole new interface.
I think it doesn't, but let's see if I can.
You know, I'm asking more, but I'm going back to my understanding of definition of a mode is something where we say you need to be compatible with.
Mhm.
That's at least that's part of it. Let me go look at the spec, but I think that's what we say.
Because we can.
No, this definitely wouldn't. Yeah, this definitely wouldn't be compatible with any other thing. You'd have to build it specifically.
Correct. So maybe it's a Bo derivative or something, but
But wouldn't the
I mean, I guess just as a side note, like, yeah, there is a potentially simple way around this, which is just have, instead of having two bumps for clock, have 4, and the clock bumps are unidirectional, and you can just loop the clock back, right? So that's still, there's still a lot of specking involved, but it is at least slightly less, sort of likely to be completely incompatible with sort of something else.
So when we say compatible, what do you mean? Meaning this phi can support, this single phi can be either RX or TX to an old one, right? So this one can sorry, basically supports the old phi.
We never defined a
Um,
mode anywhere.
Right, this would be if you build a phi for this phi can
Wait, are you
do
sharing
an,
your screen right now?
no, I'm trying
Oh.
to sort of,
When you said this, I was kind of like,
I'm trying to
Yes, you are correct. You are correct that like if you tried to use it, you know, like just for sake of argument, let's say it was talking to another by 8 or whatever, and it was 8 in a single direction. That is true. You know, ignoring spec, you know, or function of that workable.
one second, I didn't share the wrong thing. Yeah, so it basically exactly, so if we do build that, we can do it. Okay, this is all right. So this is the phi. Do you see the screen?
yes.
Okay, so there's two pieces to it, right? There is, we can talk about the symmetric piece or the bidirectional, or not the bidirectional, but half Rx or split Rx TX. So is the
I think like to me this the symmetric aspect like is I think a lot easier to solve than the RxTX in one slice.
okay? So the symmetric aspect, I guess there's not much issues on it because it's pretty flexible. It's as compatible as the other half pi.
Well, I mean, I think that's good for like Elator. So to comment, like when we thought about this initially, we thought about like using basically D0 to D7 to make it easier from kind of a link layer perspective. But I'm not sure like how much change in the like the back end of a phi you have to do say D4 to D11. But I assume that's like easier to do or easier to make compatible.
Yeah, I know that it's you know it's annoying, but it's not. It's largely speaking more digital muxes.
Gotcha. Okay, yeah, that would make sense.
Got it.
Hey,
So
but
I guess so now going to here, this is the part we have we have doubts that whether splitting TXRX. So this, if you design a phi that can support this mode, it can support the normal BOW mode as well. So it's an additional feature in a sense, right?
Yeah, no, that is true. I mean, I guess I guess how should I say this? I think what you're saying is absolutely correct. I guess there's sort of a couple of questions like how should I say this? If you wanted to have the interoperability with some other phi that was not built this way, then you would really need both the TX and the RX slices. So that sort of the reason I mention it is that in case you do need that, then you're sort of stuck paying for that in any case.
Yeah.
So it's just I think it's sort of a little bit of again a question of sort of usage, but you're correct that if you had one of these and you configured it purely for TX or purely for RX, yes, it should be able to work with some other regular implementation, quote unquote.
But if you use the configuration, then there is no area and area saving already, right? The whole goal for this one is for bit a bit is area saving, right?
Well, an example of a scenario is that let's say you have one chip that connects to two different, like it's an additional use case, right? You have one chip that has a lot of chiplet interfaces around it. If we do it in this mode, it enables us to use, say, in this 8-lane with every single IoT chip. So every single IoT chip goes through this 8-lane, which has flexibility. Now if it wants to connect to, and this is actually something we are doing, but if it wants to connect to a more traditional one, it just takes advantage of 2 lanes, one of them in RX, one of them in TX.
Yeah, but your first suggestion why we use those for bits and bits, the first reason is for cost, right? Cost is area. Then all those are redundancy and so on will defeat the purpose, right? And
Well,
this one also remove the remove the clock on the RS side, the clock meaning the PLL. So if I build the file as a bundle instead of a single bits with the PLL and bundles, then I don't have the area saving as well, right? My question is more towards the IP reuse, the physical IP reuse perspective.
So look at it this way, right? This mode enables you to save area, but if you're still using the old one, you won't save the area because you don't. If your other
so
partner
meaning
is,
that you need a dedicated file just for these modes are to be inserted inside the die, right? So if I don't have the dedicated files, I don't save the area. I use the same files that support for both, then I don't have the area advantage already, right? And if I have a dedicated one, mean the IP folks need to redesign the files just to support these modes so that I can have the area saving, right?
yes, you need to, by the virtual, you have to have both of them to be able to save the area. I correct.
Yeah.
But
So
that's
that will be an
anything
issue.
you
Yeah, I
do.
think Bunchong, you're. No, I think I was gonna say that. Yeah, I think you're pretty much in the same boat of thinking that's probably where. Yeah, it seems like a reasonable halfway point or whatever it is. Yeah, if you just say, look, there's always at least 2 pairs of clocks, and they go, and and they're always unidirectional. That just seems like it's sort of, you can then build a quote unquote normal phi for each one of them, and you can have a bonus mode that sort of from whatever reason doesn't need one of those 2 clocks. But I think it would just be, you'd pay a little bit of area for it, but it would be more straightforward to, having very close to the area savings you intended, as long as you're talking to a 7x4 or whatever the quote unquote half width turns out to be.
But
Does that make sense? Or?
I don't know if it makes sense, to be honest, because it's like the moment you add the clock, then you have to it starts to not make sense for the floor plan of it. And I mean, let's make it simple, right? You either both sides support this mode so you can take advantage of the area saving, or they don't, and you don't take advantage of the area saving. Right?
Right, but I think the point that Bunchong and I were both sort of going towards was, if you do need to be able to interoperate with something that has not done this,
sure,
then you basically have to spend the area.
Correct, but
yes.
So hear me out. Let's think of a real scenario, right, or option, right? If you wanted to have both a TX and RX option enabled, so does your link partner need both TX and RX in this scenario or not?
Okay, good question. I mean, if you need both, then yeah, basically. So you're right. There's an extra caveat to what both Bunchong and I were saying, which is that it is assuming you need both TX and RX. That is true.
Yeah, because the scenario is that let's assume the other side is more traditional and also wants TX and RX. So in that case, like, it was designed to be traditional. You can't support that one. Like, the thing is, the current BO is not forward compatible, but we're designing this to be backward compatible.
Yeah, but so let me maybe ask a kind of practical question. So
yeah,
what do you think the most common sort of instantiation of this is? Is it a by 8, or you actually think by 4 is sort of either reasonably common or more common?
We're thinking by 8 might be the more common one, but we might do more of them. You know what I mean? The idea is that you're connecting to a lot more chiplets around you.
Right, understood. So the reason I'm sorry. The reason I asked. No, please go ahead. Yeah, please go ahead.
So the other thing is that because you have this special mode, then your clock is a shift half cycle, right? That's good. But then in my sound stage, right, then my timing self, I also have to assume that if I shift half cycles forwards on the data skew and so on, do I have enough margin compared to those default modes where I just care about skew, right? So meaning that my timing off, I actually have to consider for some two scenario perspective, so to enable that it can be works in both ways, right? So that actually also add on the additional considerations in the actual implementation where I have to sound the timing. Then I also consider for both aspects as well, unless this is a very dedicated scenario.
Sorry, I didn't understand. This is when this is working with a normal file.
Yeah, the default one, and then this one, the special 4-bit, you actually have the TX shift half cycle, right? Then I cannot just say it's a shift half cycle, it's a guarantee, right? I need to ensure the cell and home margin is sufficient, right? With the skill in the timing sign off as well, just like the way of our DDRs are checking as well, right?
But again, how would be different than if you're worried about if it's operating in the normal BOM mode?
Meaning
How
that
would it?
I have to consider additional check in the timing sign so that it can support both ways, the default and this one and this mode. Unless this is a dedicated one, then it's just sign off with assuming it's a half cycle shift as well.
Okay, we
If
can
it's
work on the half cycle shift and make it disable the half cycle shift. But again, the half cycle shift is something you can. So if you're doing
I
this,
know we can work on disable it that is as well logic, but then to support two mode, meaning that my timing constraints have to assume it can be worked for both ways as well, meaning that there's additional timing sign off check that I need to consider for both scenario usage.
but let's say you're designing the half cycle is relevant when the host file is operating in basically when operating in TX, right?
Yeah,
When it's operating in RX in the normal nominal mode, that doesn't matter.
I need to ensure that the data sent over are released and can have enough sufficient half cycles cell and home margin left over, right? Because the data may have a skews when transferring over. And across those PVT and OCV effect as well.
Sure. Yeah. So maybe the half cycle we can talk about it, what makes sense across the two. So I thought of a half cycle to simplify it, and in my opinion, it potentially
but
does.
then it's just additional one that I have to consider. I can appreciate the beauty of it, the to simplify, but that is not free as well. So that's what I concern as well. That's all.
Got it. Yeah. So maybe we
Yeah,
can
that,
talk.
that makes sense.
Yeah.
Sorry, I was just gonna sort of finish explaining the reason I asked the prior question about the common usage. So if the common usage, we believe is by 8, right? That's effectively 10 bumps, if you ignore aux and FEC. So what I was basically thinking was, if you add 2 additional clock bumps, and then there's transmit clock and there's receive clock, and those are actually unidirectional. I think you can sort of conceptually then think of it as, it's sort of conceptually 2x4s or whatever that happen to be next to each other. And then the extra mode is that, yes, you can sort of, partition within the 2x4s within each other, to become, sort of more TX or more RX, as the case may be. But I think, if somebody's building a bidirectional, quote unquote, normal phi, this would be sort of a more straightforward sort of thing for folks to be able to then reuse. And it does give you the capability to interop with kind of normal other things on the other side, only paying the extra 2 bumps out of 10. So it become 12 bumps instead of 10.
But it does also reduce a lot of flexibility on where you want to place the R. Like you're adding 2-pin, we're not adding much benefit to it, but also you're constrained. If you want to continue that constraint, then you have to be very careful with how you physically place it, so that how does it connect to a different. So if it's a normal phi, it still has to be a bit more challenged, right, in terms of pin map. I mean, the way I see it,
I think actually that's solvable. So basically, how should I say this? If each, so okay, so I shouldn't have said it the way I did. If each clock is still technically able to be bidirectional, it's just that if you want to go in 8, like in other words, if you want a phi to be able to both transmit and receive, one of the clock pairs needs to be a transmit and one of the clock pairs needs to be receive. I think you're fine. In other words, I think you can avoid the particular issue you're worried about as long as just, you know, you have the statically configurable direction of the sort of clocks, but you know, you can still sort of make it so there is actually a forwarded transmit clock and a forwarded receive clock.
Yeah.
Do you see what I mean?
I think I do, but I think it doesn't, like the way I think of it is basically, yeah, I need to think about it. The way, at least what I was just thinking out loud, right? You have, if you're doing a chip, right, you're either like, it's basically like this. If you're doing to a new standard, it's not gonna be, the old one is not gonna be forward compatible. So so let's say you have a USB 2, you have a USB 2 interface, and you're coming up with a USB 3 interface. You can't make the USB 3 sort of USB 2 be forward compatible with USB 3. And also make USB 2 work at the same speed of it was designed
Yeah,
with
no,
a
no, no.
USB
I
2
totally,
So-
I
so-
completely understand what you're saying, and the intention. The reason that I'm sort of, you know, going down the path is not to attempt to land there, because yes, you're obviously correct. You know, there's no way to make that work. It's more just that I think this breaks the problem up into two steps, where the first step from a spec perspective is easy. Because in the first step, you still have a forwarded transmit clock, you have a forwarded receive clock. There doesn't necessarily have to be sort of a relationship between the two. And then you can reuse all the stuff that's in the spec already to kind of, you know, just say, hey, yeah, you know, this is how these things work. And, you know, mostly just becomes a bump placement question. Whereas to get to the next part, which is, okay, well, the receive forwarded clock is actually immediately derived from the other side's recovered clock. You know, you can still actually physically support that. There's more spec work one would have to do to really make it work, but you know, it allows you to break this problem up into two pieces, and you know, and not have to sort of, you know, bite the whole bullet all at once.
And sorry, and Elad, this is Kevin. Right before you joined, I think I was trying to make that point. You said it much better than I, but if you do it the formal way, it falls naturally into the spec, just much easier to do the spec work. If you do it where you don't have a return clock coming back to the receive data, it's almost not clear to me that it's a BOE-PHY anymore, or how exactly it looks like the way you spec timing on that receive data seems to me it would be very different. And that's what
Right. Yeah, and by the way, Kevin, I wasn't actually there when you made the comment. I thought you said it better than I did, so it's all good.
Sorry.
Yeah. So
I mean,
let's, yeah.
One thing I would maybe mention to all of this is, like, it sounds like what would happen if we basically go for a by 4 definition, like a traditional by 4 definition, where you would, I think that's kind of what Elad is describing. Then you're adding the two in the worst case, you're adding 2 additional clock bumps, but that would fall into the scheme of going from 16 to 8 to 4. And then you can describe a secondary mode that is future looking, where basically a by 8 can like send data back to another slice, and we'll figure out the clock, or it goes to another like updated version that supports that mode as well. But I think if you build as 2 by 4s, then you can connect those to 2 by 8s or 2 by 16s that are available on like a legacy bunch of wires device.
So basically, yeah, I mean,
because I think when you're talking about the future compatibility, and this not like this being like USB 3 and we want to talk to USB 2, I think in that example, what you would need to do is just like, even if you want to have this work and you support the all lanes in one direction, then you need to have 2 of these PHYs so that you can talk to a device that has also 2 slices, one for RX, one for TX. And so then that totally negates your goal of reducing bumps, unless you go to a definition of by 4, which still includes clocks with 4 data lanes in each direction.
well, yeah, it's I guess the way I so you're saying if a device needs a larger width, right? Basically, this is supporting more flexible use cases, right? So if you have a PHY that only needs 4, if it only has, if you have a device chip that only sort of needs 8 lanes and only needs 2 of them to be RX, 6 of them to be TX, this is what this one helps with, right? It enables other
but so just to clarify, I think I really like Mark's description because I sort of argue it becomes 3 steps, out of which 2 I think are pretty easy, right? So what we do is we define the by 4, sort of PHY footprint. You define a, and basically just say, okay, look, people can take 2 of these by 4s, put them together, and this is, sort of, a symmetric by, whatever, it's a symmetric by 4, but we can then just take one additional step, which is to say that, okay, within this new symmetric by 4 thing, you can now make it asymmetric by, for each individual lane, select whether or not it can act as a transmit or a receive. But when it acts as one or the other, it's always using the forwarded clock associated with that direction.
I see. So basically, so you're basically proposing to make the units to be 8 units, right?
Yeah, exactly. I mean, said differently, I think
4 units.
I think this whole thing, I think where this could land is it's basically doing everything that you wanted to do previously. It's just that, the 2 sort of caveats are that there are 2 extra bumps, right? So it's 12 bumps instead of 10. And that the first step in the spec may not be that, that you yourself have taken, you yourself meaning that one side has taken the clock that is the recovered receive clock and looping it back in to create the transmit clock, right? It's not that one's could, somebody could just decide to do that. It's just, speccing that is much more complicated.
So the one, so the one thing is that this will become incompatible with also the way you're thinking. If it becomes completely incompatible with the half PHY that you proposed.
Not necessarily, actually. So, so I think, and this is where I actually think that if we use the same footprint that is defined for the half PHY now, and this whole thing wants to be unidirectional, if we put the 2 clocks on the 2 ends, I think it might actually work out.
Got it. So basically, if we go to the half PHY, let's go here to the half PHY, the previous half PHY. So you're having clocks here, and then you would insert another clock here. Yeah.
Yeah, and I'm sorry, I'm in the car, so I can't actually see the here's, but in this orientation, if one's on the far left and one's on the far right, that's what I was thinking of.
So basically, the proposal is, so we add 2 more pens on the left and on the right. Sort of, we have basically the clock pins will sit on the left and on the right.
Exactly.
Of an 8 PHY, right?
Yep, exactly.
And this way you will have, okay, you will have still you will have somewhat of symmetric with the clock. Let's see, it can connect to the, can it connect to the sort of the other modes? It can be worked out. I can work that out.
I think so. Yeah, I mean, I having not drawn it, obviously not sure, but I think so.
Glad I'm coming late into this. Sorry, I
Okay.
got some note that the meeting was canceled, so or something. Anyway, so I'm confused. I'm trying to get out of town. Okay, so
It was canceled just for you, nobody else. Just so you know.
yeah, you were trying to send me a message there. Let's draw this out. I mean, I think that has a lot of merit. The only negative that I can think of just is the size addition. Ahmad, can you also give us the size percentage wise?
It's about 20%.
Yeah,
you would have been, Yeah, you would have been 5 bumps wide or whatever. You'll be 6 bumps wide now from the
Okay.
base front.
Yeah.
But if makes it more compatible, I mean, in general, I'm all for. I'm just giving you my initial reaction. I haven't thought it through or seen it drawn out or whatever. But so you're saying it's more flexible from a clocking and so on standpoint, right? Am I getting it right?
Yeah, I mean, yes, but sort of, there's 2 pieces of that. One is, yes, it is slightly more flexible, but I think the other is just, it's way easier to spec.
Okay. So you're saying this would be the spec, and then if somebody wants to do the slightly smaller version, they can do it, but I think having the spec, and I'm just thinking of, because this is such a small thing, adding 20% may be important to somebody, but most likely not, particularly in an older technology where the silicon cost is a lot less, right? So
yeah, I mean, I think the whole thing is still sub 1 millimeter on a side, unless you're
Yeah.
I think the whole thing is either sub 1 or really
Sure.
close to 1. So
my
for
guess
most
is that
practical
it's
chips, it's
my guess is that this is not going to be a big factor if we get if it makes life easier to get the standard out, and like you said, if it's more flexible. That's just my 2 cents. Ahmad, can you sort of draw it out, but also add the size? So, and then what I'll do is, once I get the size from you, I can just do a quick cost calculate. I know that they're I was on a call with a company today, and they were like, everything is about cost, right? So they're like, okay. So I need to draw that out, and then
I can try to work out a drawing of it.
Okay.
So the only thing is, if we add these 2 pins, we cannot remove them. So that's something to keep in mind, right?
Maybe one thing I would ask about, so this idea that came up right now is to put the clocks on either end of the 8 signal bits, so that you can talk to the by 8. I think that's your intention, right? I would say you should probably just double up on the, basically, if you do an by 4 definition, then if you want this phi to talk to a regular 8-bit slice, it will have to talk to 2 8-bit slices anyway, because one of them will be defined as RX, one of them will be defined as TX. So as a result, I would say just basically follow the same thinking we did for the 8-bit, which is, in this case, I would probably cut bits D0 to D3 and just send on D4 to D7 plus 2 clocks and make that the unit cell of basically the by 4. And then if you put 2 of them together side by side to make a bidirectional link, then the 2 clocks end up right next to one another. And then you can route out, you can go back to by 8 or 2 by 8s or by 2 by 16s if you want, and just send the data that way.
Well, that's the thing, right? You're basically removing the flexibility of TX and RX having mixed sort of flexibility and having asymmetricity, right? Let's say what happens if you want to do 2 transmit on 1 4 6 receive?
Well, and so I would say if you do take the step of the by 4 and you say in the first step what Elad was saying, make it all one directional, then you can still define this add-on mode of, now with these 4 you can decide how many are X, how many are TX, but that mode will only be supported if it sees exactly the same phi on the other end.
Yeah. So that's right now we're basically just, the way I see it, we're just basically killing this mode with 1,000 cuts.
No, I think the extra thing.
So let one thing actually, just it's good you mentioned it, because now what we were trying to do was building this on top of an 8-bit phi, right? And adding these clocks on the side becomes not really the 8-bit phi, then it is perceived 2 4-bit phis, right?
Exactly.
And then we basically say, well, no, let's just restrict it. So basically it's a way of killing it, but not really saying it out loud.
No. I would still say, when we added the 8-bit phi in the bunch of wires 2.0 revision, we were talking about smaller iterations, like a by 4 and even by 2 at least was on the table. And at the time there was nobody that saw much of a use case for basically explaining how to do interoperability from say by 4 to by 16 or by 8. But I think at least in principle, it's much easier to go that way. And then on top of that, you could still define this. Like, I think if you're going to this route of like RX and TX in the same slice, it doesn't matter by which number it is. It's always going to be very messy and will only work if somebody basically follows the exact same design. And so you could technically then go ahead and say, on the one hand, we're defining it by a by 4 slice. And on the other hand, we're defining RX and TX on the same slice, but you have to work out how that works, because like basically then that only becomes like we shouldn't ask for interoperability in that mode with existing PHYs.
Well, if I take that argument, I'll just use your argument and say, well, let's just use this proposal, and either you want to use this interoperability or you don't want to use the flexibility altogether.
No, if you use this proposal, then I think
because the idea is like, just let's not do anything and then may leave it to people is basically that's like I guess
I mean,
I don't.
I think what other people on the call are saying, like my sense of it is, if you leave it as is, you're basically you're just not getting the interoperability with an existing 8-bit slice or with two 8-bit slices.
No,
I've got a question here. Wait, Aman, excuse me for 1 second. I want to. We've got 15 minutes. I want to come back to two basic points, so that at least we are on a path to a landing. Number one, we never defined a mode very precisely ever, and number two, how do we know that interoperability is an actual requirement? What's wrong with defining a variant that doesn't interoperate if it's for a completely different market?
Yeah, no, Bobby, I think both of those are very valid questions. I guess maybe just to add a sort of further clarification, most of my suggestions are coming from just how do you get to a spec reasonably quickly without doing sort of, a whole lot of extra work, to just define what it is. And I think you can get to a spec that has almost everything that sort of the proposal originally had, again with the exception of the 20% extra area. But other than that, I think it actually hits kind of all the things you wanted.
Right, but is this as a sort of a quick, or not? Is not going to be a quick one, but can we sort of make a decision independent of this proposal on what separates a mode from a variant? And
I mean, I think your point is very good, and I personally would say if they want to, like, if Kash and Amit want to go like use this bump map because it's optimized, I think it's totally fine to say this is just another version of bunch of wires, or like call it slightly differently, and just make people aware that it wouldn't, unless you work out how to talk to an existing PHY, that it's not natively supported. But I think that there's still a lot of merit in that, because like as you said, it's for a different application, and it should be then you can optimize it for a different application.
Yeah. I mean, it does natively support Bo, right? That's basically what we're saying. But yeah.
Well, I guess that's I think what I'm not clear on when you say it supports Bo, basically, if you want to have a bidirectional link, you have to use 2 of your PHYs. That's how I see it.
Yeah, but it still natively supports it, right?
Okay. So what does natively support mean in this context? Support, as defined in the spec, means being able to talk to other modes. I mean, what separates a mode from a variant in my mind is you can support multiple modes, and a PHY that supports his multiple modes can talk to another PHY that supports only one of those multiple modes.
Right.
Yeah.
And that condition doesn't seem to be met here.
Well, I guess the question is about the basically bidirectional use within slice. If you say you don't if you don't look for that, then yes, it would talk to an existing bunch of wires PHY. If you say no, but I want both directions in one slice, that's where I would say no, you're not having interoperability right now.
Well, yeah, but that's more of a very physical. But the question is, can you have a bow that's only one direction? meaning can you have a single
Yeah.
RX? Yeah. So then
Yes,
in this case, it's compatible.
Again, with the asterisk of saying that you can only then use your phi to go in one direction to another
Yeah.
slice.
And then and we
Yeah,
can
but that's
choose
an
which direction.
acceptable thing, right? I mean, that's
No,
Yeah.
that's true. No, and I think that's easily given. It's just like that. The what complicates it is if you want to go both ways in one slice.
okay. If I understand you correctly, what you're saying is if this bidirectional slice can only operate in a single direction when it's talking to another bow slice. And so if you now need to get data into and out of this chip, you're SOL basically.
Well, or you just have to use two of these phis if you want to do
Yeah.
that.
In which case the point of being bidirectional, I guess there may be some other merit to being bidirectional outside the scope of the spec. Okay.
Yeah, I mean,
But
I guess you could say you can like if you have multiple of these phis on a chiplet, like an IO chiplet anyway, then you can say, okay, I have to spend more of my ports to just talk to legacy or like to an old bunch of wires chiplet, or I can use the optimized version to talk to more chiplets if the other chiplet has the same, like supports the same additional features.
yeah. So from application perspective, right? The way we see it is the device side is the one that's area challenge, right? Or edge challenge. And that device side has to support this mode because that's the one that's suffering from the challenging of the area challenge. If now you have a device, if you have and on the host side, you have more area, you can have support multiple devices tied to it, right? So now if you have a device that is using the traditional bow, and it means two things, right? Either it does need the area, it needs the extra pins, which in that case we can afford to assign two phis on the other side to it, or it's basically suboptimally designed. It's still you can support it with a host device.
Wait, no, something you're saying doesn't add up. If you have a tiny device, I don't know, you call it a leaf node with your new phi,
Yes.
and it's talking to a regular hub chip with classic bow, then that single slice on your device can only push data in one direction.
Yeah, but that device, exactly, yes.
So then
That's
if you want data to both come in and out of your device, you need two copies of your slice.
yeah. So in that device phi will not be able to connect to an old one. Yeah, because we basically saved area by only having a single phi, right?
Correct.
Yeah, I mean,
So,
I think this just sort of comes down to it's again a little bit of a usage question in that, yeah, basically, right, it's all about IP design reuse, right? In other words, if you pay the 2 extra bumps, then you always have a way of being bidirectional for that 20% area. Whereas if there's a chance that the thing does need to be bidirectional but also need to interoperate, the alternative would be a factor of 2. And so ignoring the spec question for a second, because I think the spec question, at least for me, was the original motivation. That, yeah, there's just this: do you pay 20% and then give yourself the opportunity to sort of talk to anybody, but always pay the 20%, versus pay a factor when you need it, but save the 20%, in the instances where you do.
Okay,
Yeah,
I think I need
correct.
to think.
Does that make sense?
Yeah. I think I
Yeah.
need to think this through, and we'll talk with Ahmad, and then
Yeah.
let's talk about it next week. And also
Yeah.
draw it out. And I also want to just do some quick math on what is. Elad, I take your point. If you want it, so you make it more flexible, but then you pay a price, right? That's the way the world works, right? There's no free lunch.
But
No,
yeah,
but
but the
I
only
really
thing
want
is
somebody
that
to explain why it should be flexible.
yeah, but the other thing is that the old phi still has to be able to support this to be able to do it, right? That's the thing, right?
Right.
Even if we do clock on both sides, it doesn't mean the old phi can support it.
No, we will need to double check routing and things like that. But I guess, again, not having drawn it, I could be entirely wrong, but I suspect that's not too hard. Like I think that's reasonably doable.
Yeah, but you have to make the old phi design it to support this mode.
No, I think that's where like the question about basically a by 4 definition would come in, because then you could
Exactly.
just
So
treat it as
you
2x4s going into an old phi. And I
exactly
think
then
that's
you're
easier
sort
to
of
do
yeah, but you're
than
now restricted to be four lanes rather than sort of fixed lanes. You know what I mean?
That's true. Yeah, no, it's true. But at least it's a way of getting data back, like basically to and from your the edge
But-
device.
But that
and
edge
talking
device
to legacy.
wouldn't. But that edge device might not need it. Basically, it doesn't have the like that operation
So
to have a symmetric.
technically, yeah, technically this isn't. It's just, I'm not as worried about the by 6 TX by 2 RX and things like that. I think those are actually solvable. It's solvable in sort of the brute force way, but I think that's fine, right? So for example, let's say you really wanted to do the by 6 and the by 2, and you were talking to 2 by 8s on the other side. You just zero pad on the things that are missing on the other side. But physically, I think you can still do it.
So like even to physically like tie the other pins to ground and say like they're always receiving grounds no matter what.
Yeah, again, somebody has to be clever in the back end on interpreting it, right? But
Yeah.
besides that, that can be done.
I guess that is a good point. Yeah. But I think like so then it only means you could be flexible in how many RX, how many TX, but you need that second pair of clocks to enable basically the signals from this one phi going to 2 like
Wait, so, hey,
legacy
Yeah,
wedge wise.
exactly.
wait, guys, we're down
Exactly.
to 5 minutes. Either Elad or Marek has to sort of come back and say why we need this compatibility.
No, I mean, that's something I think for us as a group to determine. I think, and for Kash and Amma to say, do they like they can define this phi without interoperability in mind, or with only interoperability with basically one direction, if that's like if that
But
serves
I
their
think
market
if
Yeah,
purpose.
and Boppy, sorry, just to clarify, I'm the whole reason I ended up in this thing was not actually interop. It's, as I said, it's for me, it's more importantly about how you spec it. And
Okay.
this other thing we're talking about, I know how to spec. The other one, somebody's gonna have to do heavy lifting to figure out how to spec that.
Okay. And then how the second question is maybe in the next meeting we should at least in the Bo 2.0 clarify what the mode versus variant itself, what we mean by a mode and what we think a variant is at some point. Should we just put down in writing that a mode is something which we think will be interoperable with all previous definitions, other modes? We never actually put it down anywhere.
I think the closest we said was that something along the lines of, phis have to be able to operate at modes that are slower than themselves. I don't remember if we put a limit on how far down it had to go, but because I think the literal statement you made, we actually can't say for the USB 3 versus USB 2 reason, but you can say that, something along the lines of, sort of future modes have to be backwards compatible with, future and or higher rate or whatever modes have to be backwards compatible with
We do
older
say that.
/ lower rate modes.
We do say backward compatibility. That much I remember, unless it got deleted in some recent.
No, we do. We also say I thought we also said that a Bo phi must be able to support I don't remember if it was 2 gig or 4 gig or what, but I thought there was a sort of hey, you have to be able to operate at this lower data rate.
So one thing is that when the analogy of USB 3s cannot be backwards compatible with USB 2s, that is USB 3s come later, right? Now we are proposing a 4-bit slice, and then the expectation is even lowest performance, not the higher. So I don't think that analogy is logically applied here, right? In terms of backward compatibility, and then the IP reuse, the physical IP reuse, and the IP design, that is another side questions, right? So that's my view. And also the half-clock age shifting, and that is also introducing another timing sign-off mode that I need to consider.
Yeah, I agree.
I mean,
Yeah, then
if we
one
use
last.
that speed as a constraint, like we can argue Bluetooth has gone we have low step downs in speed for support for lower power. But anyway, I think, yeah, let's talk about the modem thing next meeting. We'll work on our homeworks to see
Yep.
additional lines. The only challenge would be if we make the device file, basically you will have now two separate type of 8-bit modes, right? One of them would be bidirectionally enabled, which are footprintly, they're not match footprint unless we decide to say we'll tag the extra clock to the traditional 8 to the half phi anyway.
Yeah, I mean, you're correct. I mean, which is this. I think in general, for most of the people that are going to be landing in these cases, you know, a one row or column offset, you know, for however time frequently these are repeated is probably not that big of a deal, because I suspect if you're in these narrower things, you're probably not repeating them a whole lot in the beachfront anyways. So I think that's generally okay. You're right, you know, that there is a mismatch there. It's just, I think at some point we should say, yeah, that there is a mismatch, you know, people will route around it. You're probably not doing this, you know, for the super high data rates anyways, you know, I think it's okay.
So the argument is that we do. So are we thinking of making the half phi to be to include this as well, as a so have two pairs of clock in a half phi?
No, what I'm saying is I think just leave the original by 8 alone, and then effectively this becomes a special way of concatenating 2x4s.
Yeah. So that's sort of something that I guess, we're splitting a half 8 lanes that way. That's like one of the interest in this was that at least keep the footprint and physical similar, right? That's one of those things that makes it the physical reuse easier. A lot of these functionalities we can design within the phi, but
Yeah, no,
having these,
I understand what you're saying. Like what I'm, it is right. It is similar, right? It's just there's one extra, you know, it's a 20% difference or whatever, right? And so
yeah.
what I was attempting to walk through was, when do you care about that difference and what does it do to you? And you care most if you have a whole bunch of these repeated along the die edge, and you sort of accumulate that skew, right? That's when you care the most. It's just that I suspect, I could be wrong, I suspect that's a fairly infrequent case, just because most likely if you have a lot of die edge, you probably wouldn't do a lot of by 8s, you do a lot of by 16s anyways.
Not necessarily. Like, at least in our use case, we expect to have certain number of these because our sort of host chip is connecting to many, as an example, to many device chips, right? So this is specifically use case for when you have like a processing chip that has a lot of like,
understood, but that's actually okay, in the sense of, basically you were gonna need scribe lines and stuff like you need separation between the device chips anyways. So even if those footprints matched perfectly, you were never gonna get the device chips right next to each other. So arguably this is in some senses, you know, well, anyways, yeah, you would need to spread no matter what.
yeah, I need the spread, but I would, yeah, it's basically the area, extra area. Yeah, I see your point. You're more worried about the when you're lining up two different chips that are gonna talk on these ones, and then
Exactly.
they will, yeah.
Yep, exactly.
And just basically parallel wires. Yeah. So we can think about it, sort of talk to people, see if the extra clock bits make sense. I guess the question of whether those, whether those pins would be sort of, yeah, I mean, but those extra bits would make sense, and we want to bring it to the site, and also whether what we define as a sort of a new standard versus or operating or something. I don't. What was the terminology that you were using?
Mode,
A
I think,
variant,
is
a variant,
is
a variant versus whatever.
Variant
right?
versus mode, yes.
Yeah.
Anyway, so what can I request something for the next week? We actually, if people can go through, so I don't know if Boppy, you can post this somewhere, and people actually, based on this, I mean, putting the pin map aside, if the people can go through the slides and have some technical feedbacks as pertains to this flow bump map. And then we can also talk, a lot of those feedbacks would applicable either way.
So, let's see. Everybody on except it's Boon Chong. Do I have your email address? I forwarded. Forwarded. I'm not going to solve this until the middle of October or something. I'm kind of dead. Here, I'm just going to forward. I forwarded Kasha's slides. Boon Chong, do you have them?
I just type my email here.
Sorry.
I just type my email here in case you don't have mine. I just type in the chat.
Oh, you put it in the chat. Okay.
Yeah.
Got it. Is it still? It's still midnight right now, right? For you?
Yes, it's okay.
God, man,
Yeah,
that's some persistence.
that's a lot of dedication.
He loves your 8-bit mode, man.
All right, guys, I got to run as well. Thank you. So I may not be on the call next week because I think I'm on a flight right around then. But see you guys. Bye.
Thanks, everyone.
Thank
All
you.
right, thank you.
Bye.
Bobby, can you hear me?
I can hear you.
Yeah, can you forward the slides to me too, please?
Yep, I am.
Okay. And then the CMU thing, is it possible to attend in person or?
Yes, I think so. I think so,
Okay.
yes. Give me another couple of days to figure it out, but yes.
Okay, sounds good.
All right.
So sorry, one last question.
Sure.
Is there a background document, a paper? I'm following your 8545 thing, but is there a background document or something I could read to kind of come up to speed?
That's what I just sent you, the proposal. That's the.
Oh, okay. Okay, got it. Thank you.
All right.
Cool. Thanks. Bye.
Thanks.